Euclid's fifth postulate gained so much importance that many mathematicians were convinced that it is a theorem, and therefore they tried to prove it by assuming various other propositions which are equivalent to it. We are going to see those equivalents of Euclid's fifth postulate given by different mathematicians. One very prominent one is, through a point not on a given line, exactly one parallel line can be drawn to the given line. Let us say we have a given line L and P be a point not on it. So P can be anywhere, here, anywhere. Let's take it over here. Now it is saying through P there exists only one line parallel to it. Now we know that P is a point and multiple lines can pass through P. But there will be exactly one line which will be parallel to the given line L. And this is called Playfair's axiom. Now the question is, how is it equivalent to Euclid's fifth postulate? Let us see how they both are saying the same thing. Euclid's fifth postulate says, if a line crosses two other lines and the angles on one side add up to less than 180 degrees, then those lines will eventually meet on that side. While Playfair's axiom says, through a point not on a line, only one line can be drawn that doesn't meet the original line, or there's only one line just parallel to the existing line. Now, both of them are describing parallel lines just in different ways. Euclid's version is telling us when lines will meet, or when they will be intersecting, or when they will be not parallel. And Playfair's version tells us how lines won't meet, again, when they will be parallel. So if you just accept one, you can prove the other. They are leading to the same geometry. We have one more equivalent, which is, there exists a pair of lines everywhere equidistant from one another. And this was given by Posidonius. It means if you have two straight lines, the distance between them is always the same, no matter where you measure. Euclid's fifth postulate is all about parallel lines. It says that if certain angle conditions are met, two lines will eventually meet. That is, when they're less than 180 degrees, they'll meet. And if they're exactly 180 degrees, they'll not meet. So saying that two lines are everywhere equidistant is just another way of saying that they are parallel, or that they'll never meet, which means we are assuming that the fifth postulate is true. Let's move on to the next one. If a straight line intersects any one of two parallel lines, then it will intersect the other also. Now, this is also called Proclus Axiom. In Euclidean geometry, parallel lines are in the same plane, they never meet, and they behave consistently when intersected by other lines. So if a transversal crosses one parallel line and the other line is truly parallel, then it must cross the second. Otherwise, the geometry breaks down. So this rule depends on the fifth postulate being true, that two parallel lines are never going to meet, and if one transversal is intersecting one line, it will definitely intersect the other one as well. We have one more equivalent, which is straight lines parallel to the same straight line are parallel to one another. So let's say we have one straight line, this green color, and it is parallel to this blue straight line. If I say that they are parallel, that means they'll never meet. Then we have one more yellow line, which is parallel to this blue line. That is, once again, these two will never meet. So green and blue never meet, yellow and blue never meet. That intuitively means that green and yellow will also never meet. The last equivalent is, the sum of angles of any triangle is a constant and is equal to two right angles or 180 degrees. This was given by Legendre. Now let's have a triangle and call it triangle ABC. This is angle theta, alpha and beta. In order to see how this is equivalent to Euclid's fifth postulate, let us see how this is saying the same thing as the Playfair's axiom, which is again equivalent to Euclid's fifth postulate. Playfair's axiom says that if you have a given line BC and a point A not on this line, there is exactly one line which is parallel to the given line. So L here is parallel to BC. Now if these two lines are parallel, AB is the transversal. So then this angle and this angle, they make a pair of alternating angles and they are equal. So this is alpha as well. Similarly, if this is beta, this angle will be beta as well. They make a pair of alternate interior angles. Now, if you look over here, you have alpha, theta and beta. They are lying on a straight line and they're making a linear pair. So alpha plus beta plus theta, they're equal to 180 degrees. And these three angles are the angles of the triangle. So sum of all angles of triangle is equal to 180 degrees, or in Euclid's language, 2 right angles.